Join us in Miami for Code Remix Summit. Attend hands-on sessions with some of the best industry experts. Looking for immediate ROI by attending? Bring a relevant business case and work directly on solutions affecting your organization in the hack track. Bring your problem, bring your laptop, and walk away with work done for your boss. Register today for Code Remix Summit.
Hello, everyone. So good to be here. And I am joined today not by our beloved Tim Tabik, as he is busy snowboarding in the mountains of France, Switzerland. He's normally in the Netherlands, and I know he has to go, east and south to find some mountains to snowboard on. I don't know the precise location, but that's fine. He doesn't need his exact whereabouts being reported on a live stream. But that does leave just me here to host you today for another edition of Code Remix Weekly. So let's jump right into it. To begin with, this week's announcements are that, as usual, there is a conference coming up that includes Tim. It also includes Merlin. And this guy is in, where is this? This is in Analyze, Automate, and Scale Your Migration. This is a conference, the Conference for Software Architecture in Munich. That's right. Apologies for my disorganization. So if you're in Munich or the general area of Europe and could take a lovely high-speed train, for example, you may wish to check out their session. It's going to be good stuff. Relatedly, Tim has a meetup coming up on Monday, February 10th at the Colm Jug, or at a meetup. So if you want some one-on-one time with Tim to write custom open rewrite recipes, well, it won't be one-on-one, but you would be there with Tim and he could help you write or advise you on open rewrite recipes. And we also have coming up this Java user group visit. Oh yeah, and that one's a virtual event, so that one could be attended by anybody. But this Java user group in Saarland, will have Merlin there. So if you're in or around Europe and want to see Tim or Merlin, and they're both great speakers, I would recommend checking out one of those events. And speaking of having someone collaborate with you directly on authoring recipes, I remind you that at the upcoming Code Remix Summit in Miami, there will be a hack track where Tim and myself and other recipe authoring and open rewrite and Moderne experts will be on hand to pair with you on whatever recipe development question you may have. If perhaps you are working on a recipe or want to affect some kind of change across your code base, but don't feel that you quite have the skills or knowledge to execute on your grand plan, bring it to us and we could provide advice and help you out. And I, of course, should mention that there is a Moderne VIP code that you can use to get a big discount on this. And that exact code is all caps Moderne 3 VIP. So VIP. So go ahead and put that code in when you register here on the Code Remix Summit website and get a nice little discount on coming to the conference that will help you to affect change at scale within your organization. Very good. So I think that's all the announcements we have for this week, although I guess we did do a release of Open Rewrite very recently, or perhaps 8 hours ago, putting out 8.44.2. Not sure if the latest CLI for this is out yet, but as usual, getting a lot of good fixes in here. Stuff coming up with a whole variety of little changes. So if you were seeing any build errors related to lombok.generated and you were like, my project doesn't use lombok, what's that about? Be sure to grab this release as this fixes that bug. And beyond that, I think we'll just get into it with today's topic, which is some custom recipe authoring. In the theme of of the new year and of coming up with useful recipes to modernize our software and to get rid of the old stuff and the old cruft that we don't need anymore. There is a whole lot of recipes on my to-do list in terms of getting around to implement, including some enhancements to existing recipes and some brand new stuff. So at the top of my kind of plate for recipe authoring, I have a little more dependency management, and we'll see how far we get on this. Maybe we'll get into authoring some Java 21 language migration recipes. But one kind of feature that we already have this recipe called remove redundant dependency versions for Gradle. And this is handy as it can remove explicit dependency versions where they are not necessary. Right now, it is focused on when you are importing a BOM. If you're familiar with Maven, this is but not Gradle, this is the equivalent of having a dependency management section, which brings this BOM into the import scope, which is to say this line provides all of the versions that are necessary for this line. So this explicit version can be removed. Then I want to extend this as our popular find and fix vulnerable dependencies recipe, which I suppose while we're talking about it, I could run just to demo quickly what I'm talking about. But yeah, our find and fix dependency recipe and other sources may add to Gradle build files dependency constraints, and these constraints can include version numbers. And in the default arrangement, here's find and fix vulnerable dependencies. I'm just going to run this on default real quick. So find and fix vulnerable dependencies is going to go and add Gradle dependency constraints, which are a syntax which can affect the resolution or what version of a transitive dependency you resolved. And these are typically soft constraints. So if you that are subject to Gradle's newest wins dependency conflict resolution policy. So here we go. We've got some results from running this recipe back. Yeah, and here we go. We see in this Gradle file that the find and fix vulnerable dependency has added several constraints to manage the version of transitive dependencies. Now, these, this pin to Tomcat embed core, it can bring you up to a newer version of that dependency, but it won't bring you down. Like if you upgrade some other dependency that is now pulling in Tomcat embed core 11, this constraint becomes meaningless. It won't actually pull you down to an older version of the dependency. It will only bring you up. There's a different form of constraint that you can apply to Gradle if you want to pin something back, but at least as this is written, it is exclusively for pinning forward, which of course means that this whole section, becomes junk as soon as it's not actually bringing any dependencies forward. So what I want to take a crack at is enhancing the remove redundant dependency versions recipe in order to handle this use case. So that we can use it to clean up these blocks of constraints once they are no longer relevant, and keep our build files looking evergreen. So to get started with this, what I think we need is a test case where we could do something like we could take one of these existing test cases and switch it from using the platform to using a constraint, and then we could adjust the recipe to implement it. Per usual, I find that let me click that. Per usual, I find that recipe development is well done in a test-driven manner. So let's see. So for this test, what I want to do is not necessarily have anything about a platform, but I want to say if we were just importing some Spring Boot dependency that brings in Commons Lang 3, and I had a constraint for Commons Lang 3. Now, rather than doing that, maybe the place to start this is not in this build file, but just go make a scratch file. I typically have a project over on the side that has only that just has some build files in it so that I can try things out. So if in here I say, well, what dependency do we want to take? Maybe something Spring Boot related is a good idea. So I'll just look up some Spring Boot dependency. Spring Boot starter. Yeah, see it's Spring Boot. So if I look at Spring Boot, this latest 3.4.2, then it has a dependency on Spring Core 6.2.2. And I just don't care for the map style of dependency declaration. So let's say we're taking a version of Spring Boot 3.4.2, and we have a Spring Core dependency, or we have a constraint on Spring Core to some version earlier than 6.2.2. So if I have here constraints pluralized, and I were to say, where did this go? It's just looking at it. Yeah, so if I had a constraint that looks like this, and this we're instead pulling us back to Spring Boot, what we looked up here. Yes, yeah, so this was using Spring Core 6.2.2. So I'm just going to set this to an earlier version to say 6.2.1. Let's leave a quote. All right. So this constraint that I just implemented here should be useless. This should do absolutely nothing because, as we just saw on the Maven repository website, Spring Boot 3.4.2 brings in Spring Core 6.2.2. And if what I have told you about the about this is true, then this constraint should have no effect on the version of Spring Core that actually gets resolved. In which case it's redundant and our recipe should rip it out. So I'll ask Gradle real quick to check my assumption. And let's just say we'll do dependency insight, and we'll say we'll look for the dependency Spring Core. And so this should tell us that despite this constraint, Spring Core 6.2.2 is being resolved, in which case this is fully redundant. No dependencies. Oh, does Spring Boot 3, what if I just say Spring? Okay. Oh, I got to declare some repositories. Yeah, fair enough, Gradle. Fair enough. Let's try that again. All right, now we're getting some dependencies resolved, but I'm really interested in Spring Core in particular. Yeah, exactly. So yeah, we see that according to dependency insight, we are in fact resolving version 6.2.2, and so this makes for a good test case for the recipe change that we want to see. So one of my favorite IntelliJ plugins that I've learned, not recently, I've been using this for a while, is that if you hit Control twice and hold on the second time, you can do a multi-line cursor, which I find is really handy for indenting text blocks, particularly if for any reason the text block, the auto formatter was not going to put it right where you like it. Okay, and so what we want to do here is have this build.gradle remove unneeded constraint. So what we want this recipe to do, which I'm pretty darn sure it doesn't do right now, is get rid of this constraint on an older version of a transitive dependency. Maybe I can make this test case more self-documenting by taking advantage of this because field. Variable is resulting 6.2.2. This constraint has no effect and can be removed. So let's see if what this recipe currently does. My bet is on nothing. But I haven't actually looked that closely at the implementation of this recipe recently, so maybe it will surprise me and this work is already done. That would always be nice. Every now and then you rock up to a problem or a bug report and you're rolling up your sleeves, getting ready to dig into it, and you find that that someone else has already done the work for you. Unfortunately, that sort of surprise doesn't happen often enough. Yep, recipe was expected to make a change, but made no changes. So let's get into the implementation of this recipe and start evaluating where the best place to add some constraint handling logic might be. Pop over remove redundant dependency versions implementation. Zoom in a little bit on this. Cool. So we see that this is not a scanning recipe. This is just a regular recipe, so it can make all of its decisions local to a single file. It uses a precondition to limit its application to just build Gradle scripts, and uses a groovy visitor in order to get its work done. And it looks like we have a couple override, or we've got more or less just the one override here, or I mean just the two overrides. One for visit compilation unit, which is the high level surrounding LST element within which the rest of the file is based. And this guy is looking for, oh, and this actually declares an inline visitor, which is, this is a pretty advanced, well, I don't know. It's, I don't know if this counts as an advanced technique. I'm going to say this. This is an advanced technique, or at least demonstrates an advanced understanding of the visitor pattern where, Shannon, the original author of this recipe, wants to apply some specialized sub-visitor within visit compilation unit. He wants it to go do some work before even, he calls super.visit compilation unit at the end of this in order to go into visit method invocation. So this inner groovy visitor that he has visits method invocations, and it looks like it is looking for, yeah, okay, so it's filling in this platforms. Yeah, okay, so this is filling in this map of platforms, which, a Maven, from a Maven perspective, these are just, bombs being added into the dependency management. So that's what he's looking for here. I think what I am looking for is redundant dependency constraints. So I think we want to have, now the kind of question is, could I just piggyback something about constraints into this visitor, or should I have an entirely separate visitor in order to design this recipe in a way that the code is maintainable? I don't really want to mess up what's in here now, which is quite oriented around the platform stuff. I think making this one code path handle two substantially different scenarios would be regrettable, or just make the code less maintainable, which would later on lead to regret. So the change that I am thinking about making is, do I put in another kind of specialized sub visitor just like this one, which goes and similarly goes and populates, some field related to constraints, or do I do something else? Now, if I do make this second specialized sub visitor that's just about constraints, that obviously kind of doubles up on traversal, right? So we'd have this visitor would go and traverse the entire tree, and then maybe another specialized sub visitor right after it also goes and traverses the whole tree, and that is maybe a smidge regrettable from a performance standpoint, because actually we'd have this recipe would have 3 complete traversals of the LST. Right now it is 2. one from this visitor and another one from the visitor, which encloses it. So if I add a third, then it might have some small hit on performance, but I mean, what's even on a large repository? That's 3 or 4 traversals of, and that's just a couple extra traversals of a dozen files, 2 dozen. So it's probably not that big a deal. So let's see. So what is the information that I would most need in order to deal with these constraints? So I think I can probably, I don't know that I don't need to look for platforms the same way he does, or the same way that this code does, because I should kind of be able to visit the platform, or not visit the platform, visit the constraint, see that from the Gradle project metadata that we're resolving a newer dependency version than that, and get rid of the constraint entirely. So if I just go and look at my test case under the debugger, let's see what we can tell from the Gradle project marker that gets generated. Just give this a second to warm up a Gradle daemon in order to produce the Gradle project marker. Cool. So here in the Gradle project marker, which has all of the metadata, we can go and look and say, at the I don't know, the runtime class path. Yeah, that would be a good one. That we have, it's requested Spring Boot 342, and that involved, resolving Spring Core 622. This Gradle project marker plus visiting the method invocation for a constraint should tell me everything I need to know. So I don't need. So this part of the logic, I think, can be is a little easier than what's currently in the recipe. And I think I will start by doing a custom sub visitor in order to handle this. So I could do this all in this current visit method invocation, and then the trick is just sorry, I'm getting lost in thought considering what code changes I'm going to make. Forgive me for being primarily a software developer and only off incidentally or accidentally perhaps a live streamer of software development. I don't know if you guys if anyone in the audience or watching the VOD later is into pair programming. We Thanks. We too get lost in the sauce. I appreciate that. Yeah, I've always found like pair programming difficult. Like I feel like I spend so much of my brain thinking about like the person I'm with and talking with them that the debugging neurons get overbooked, or maybe they just can't access the resources they need in order to do both. I found that pairing works really well for debugging, but for writing new code, I struggle with it, or at least I struggle to be in the driver's seat with it. I've been along for the ride when someone else has been coding something, providing encouragement and insight and such, and that can work. Yeah, I wonder about pair programming, about your pair programming experiences, because doing live coding on a live stream feels a little bit like that. So yeah, I don't know, maybe let's just do this for now so that I can avoid messing up anything that's already here. I will, so visitor, I will provide my own specialized sub visitor. Well, what don't you like about this? Oh, right. You want a typecast, of course. Yeah, it's still going to be a compilation unit afterwards. Don't you worry, Java compiler. Don't you worry. So now what I want to do is I want to visit method invocations, and I am going to start off by continuing the traversal into sub-elements. This is an ever important thing to do when writing a Java visitor or writing a code visitor, as methods contain other methods. And that is never more true than in a DSL situation like in Gradle, where each of these words is a method invocation. So if I don't call super.visit method invocations here, I would never proceed from visiting the dependencies method to its interior to visit the constraints part. So let's see. So what I am kind of looking for here is I want to find that I'm in the constraints block, and then I want to maybe loop through every method, every statement within the constraints block, and check check which are redundant. So let's see. Do I have any type attribution for this constraints method? If we were parsing Java here, we would have full type attribution for everything. But in the case of Gradle, we cannot always fully type attribute what's in a Groovy script, as they are dynamically typed. Okay, so I'm just going to check in the debugger. Here I'm looking at the dependencies block. I kind of want to go in to its arguments, which is a lambda or closure. Yep, a lambda. And inside of the lambda's body, we should see that there are, here's the constraints function. And this guy is a method invocation. Yeah, okay, so we do get type attribution for this, which is great. So we could do a matcher. So let's see, I can do a matcher where I can say something like, good job, Copilot. Let's see, is that correct though? Are you? So the clear type is just dependency handler spec. So I think this is just, so you're fully qualified. Yeah, and this name I think comes from the All right, so let's spell constraints correctly. Constraints. There we go. Okay, so I'm going to say if the constraints matcher matches M, I'm going to do an early return. So let's hit this in the debugger and both validate that everything up to this point works the way I think it does, and be looking at just the method invocation that is relevant to our recipe here. All right, cool. So this has successfully matched the method we're interested in. And so kind of what I want to do here is I want to go through the arguments of this guy, and will these, the argument is a lambda, and its body is a block, and its statements are, return, implementation. And if I look at this method invocation, is this guy going to be, okay, so this guy also has, this is a declaring type, dependency handler spec, return type, return type of dependency. Okay, so maybe what I will do here is, so I kind of want to unwrap M and say, so I want to affect its lambda. Now I kind of have a choice. Do I want to operate at this level, or do I want to continue to use visitors to abstract away the traversal of this element? And I'm not sure which is going to be more readable and easy to maintain off the top of my head. Maybe I'll start off with just modifying this inline. So in the get arguments, I fully expect this is going to contain a lambda. So I'm going to say if m get arguments dot size it's not equal to 1, we'll return. If it's not a lambda, we'll return. Whoops. And I expect this is currently going to, evaluate to false. Yep, because these conditions are met. Okay, and so the first arg is going to be that lambda. Oh no. Maybe rather than writing this, it would be better for me to nest yet another visitor. And part of why I'm nesting visitors like this is that this method invocation, looks a whole lot like this method invocation, but one of these is adding a dependency and one of them is adding a constraint. And so I want the kind of context. I kind of want one visitor to go in here and match the constraint block. And then within that, I could have a visitor that anything that looks like this, it knows is a constraint, just because of the context it's called from. So maybe that is what I will do and have another kind of specialized sub visitor within here that that really kind of demonstrates how you can use visitors a lot like control flow. Like this is very similar to just having two nested loops, right? So let's see. So we have now gone away. So I will say m equals new groupie iso visitor. Execution context visit non-null. Wait, is it fair? Yeah, this isn't going to return anything that isn't null. And you need to be cast to a method invocation. And what I actually think I want to do is I want to visit m, or it's fine to further visit m. And now what I want is, I just want to make sure that the constraints function itself, what is the return type of this method invocation? If I look here, this has a return type of void. Very good. And the methods I'm interested in all have a return type of dependency, I think, is what we saw in here. So if I go look in this element again to refresh my memory, the parameters, unwrap all them lambdas to get to the method invocations that are interesting. Nope, that's j.empty. I clicked on the wrong thing. Element parameters. Oh yeah, it was body that I wanted here. So the statements inside of here for this implementation of return Spring Framework Spring Core 621 is a method invocation, and its method type is so it has a return type of dependency and a declaring type of dependency handler spec. And the thing is, the name here could be anything, right? It could be the name of any of the dependency configurations. So I'm not going to use a method matcher, which, well, I guess I could use a method matcher, couldn't I? Oh my! Oh, hold on. I just heard a bunch of stuff topple over in my house. I need to check on what that was. Probably just a cat, but one second. Is everything fine? Doesn't seem like an emergency, so I need to get back to my live stream. Okay, good news. The toppling sound that I heard was just a cat deciding to redecorate our house plants. The cat thinks the plants look a lot better when they're scattered over the floor. My partner doesn't agree, but I imagine they can hash this out. So I wonder if I could simplify this. I don't know if I actually need kind of the two loops here. I don't know, because I can look at this type information, and so I don't think I need this inner visitor. And I think rather than doing a constraints looking for constraints, here I could say I want to find methods declared on dependency handler spec that have. See, this doesn't let me do, like this won't let me do anything by return type, but I could say here, if am.get type get method type, get return type, and I could say type utils dot is assignable to. Assignable, what I want to do? I don't really want to do assignable. Well, assignable could be fine. Is of type. So that one, I kind of want one that's just a string. Is, how am I forgetting this? Type utils. Yeah, I guess is assignable to. Should work here. That should be fine. All right, type utils dot is assignable. And the first one of these can be a string. And this is where I want to say that I want to filter out things where the type is not API.artifacts.dependency. So we're going to say if it's not a dependency, and I already kind of know this isn't going to be null because the type isn't going to be null if the constraint matched it. And I can just add this to the previous thing, as this is just another guard. Let me just check that I wrote this correctly by evaluating this expression. Yeah, so this is true because, of course, right now, yeah, we're visiting the constraints method. Cool. So now that I've added this condition to further filter down this visitor to do only the things we're actually interested in, let's restart the test and hit this new breakpoint. And then the debugger should have us kind of really focused on the method. Have us really focused on the method that is the one that we want to remove. Oh, I see that I thank you, IntelliJ, for doing that squiggly underlining. I don't know about you, but I can never put all the ends in the right place when I write dependency. And that probably isn't a problem for most people, but I just find that I write the word dependency at least a few times every day. And I think it's just these repeated ENs. One of those N's likes to migrate to the other side of the D from time to time, which is not helping me. All right, cool. So hey, now we are limited down to just this method. And so now all we need to do is make a decision about whether or not to remove this method and return null. So, and returning null counts. So we kind of already, let's see, do we already have access to, yeah, so here's the Gradle project is already there. Yeah. So what I kind of want to do is go look up the configuration from the Gradle project marker and see if, that's right. So this guy's going to be placed into the implementation configuration, but this isn't a resolvable configuration. So what I actually need to do is find a dependency configuration extending from implements, which has the resolve dependency at a newer version, and that would tell me that this is safe to remove. So the configuration name is going to be the method name. Yeah, because the method name is implementation. And so now I want to say GP configuration extending from. And that should never be null, but just in case it is, we'll return early. And so now I also want to say, I kind of want this configuration or all configurations which extend it. And if any of the configurations, either the configuration itself or any of the configurations that extend from that configuration have a newer version of the dependency than the version that is in the constraint, then we could remove the constraint. Yeah, so here's the implementation, and I guess what I will say is because if this was resolvable, like we could have, if this were resolvable, we wouldn't need to go anywhere else to make this decision. So I guess I could say, maybe we could make this, if we make this a list and flat map it, I could say something like optional. I want to do optional. No, I want to stream. So I got the configuration, and what I kind of want is GP configurations extending from C true. I feel like I should encapsulate this in a function because this is kind of messy. So let's see, I could put over, wrapping this in a function might help me to think about it better. So, okay, we're inside this visitor. Here's a visit method, so I'm saying Boolean has or new equal or newer version in use. And what I will say here is, yeah, because basically what I want to do here is say, you know, if equal or newer version is in use, you know, we want to return M or return null from here to filter out the declaration that we're not interested in. So what I want here is for what do I need to have in here? I could just pass in the method arguments. I guess one other thing we should filter on is that I only really want to deal with the form of this that takes a string here which fully specifies the version number. So I don't want to mess with any constraint that isn't of this style, as there are constraints that can pin back a version. I think those are strictly or required. I always get those mixed up. I have to look at the documentation, but either way, for now, we only want to deal with this kind of constraint. So maybe I can do a little bit more filtering to further simplify down the problem we're working with here. Let's see. So GP configurations equals null, greater dependency configurations. This is, well, I think this guy is going to need to take the Gradle project, although this is already a field on the, yeah, okay, so that's already available to us. So I just need a configuration name, and I could say string dependency notation. It's the dependency notation, cool, yeah. So so our dependency notation is going to come from, move this code into this function. Maybe I'll say should remove redundant constraint. I think that spells out what this is doing. And so this one, I guess we don't need this anywhere else, so I can get rid of this variable, just inline that. And now the thing I just need is this dependency notation string, which is the first argument to the function. So this is well, I guess we should return early just in case, but let's write this before I do that. So this is going to be m.getArguments, get 0, and this, I'm going to cast this to a j.literal. And don't worry, I'm going to go back and return early if any of these conditions are not met. Get value, and you are a string. Yeah, so if I were to, and you're warning me that I haven't checked that any of this stuff is true before I blindly start casting, but yeah, so this is the string I want to get out of here. So let's do some more early returning in case any of this is not the case. So let's see, if m.getArguments.size is 0, and we're going to return early, or if m.getArguments.get 0, if you're not a literal, I'm pretty sure it always has to be a literal, but pretty sure is how you get runtime errors. Yeah, you should probably be is empty. So if you're not a literal, or m.getArguments get 0, .get value. So if you're not a literal, you're not a string, and that literal, oh yeah, you're going to need to cast. And this is a little bit ugly, but maybe I can prettify it later. All right, so we would not, if I've written this correctly, this should all evaluate to false, as we are currently looking at the, yep, evaluates to false. We are currently looking at the case we are interested in. And let's see, what are you complaining about now? Get value might be null. Well, I did just, I've already validated up here that it is in fact a string. But it's complaining that this guy is, I'm going to say that I think this handles the data flow issue sufficiently, so let's suppress that constraint. Okay, so now let's get into our should remove dependency function. So C is, so I could say if C is resolvable, then I should be able to look in the resolved dependencies directly in order to make my decision. Otherwise, I need to look at the parent. And otherwise, I need to look at the parent configurations. So should this be recursive? Rather than passing in a configuration name, should I pass in the a configuration so that I could say, well, anyway, let's do one thing at a time. My mind is branching out to consider other possibilities in code paths, and that is distracting. Okay, so if C can be resolved, then we just want to say find resolved dependency. We should split this dependency notation into 3 parts. So if it's not, because it might just be, this dependency notation might be group : artifact : version, or it might just be group : artifact. And right now we only want to deal with all 3. Let's see, so should remove false, false, false. Okay, so C is null, returning false. So let's split this dependency notation. We're going to split it by, nope, don't want to iterate over it. So string group. So if split length, if it's not exactly 3, we're going to return false. So now we know we have string. Okay, cool. So now we've got a group artifact version coordinate for this, and I could say if this can be resolved. Let's hit our breakpoint again, so I like to have the debugger going. Okay, so we successfully got Org Spring Framework Spring Core 621. So I have all the information I need in order to go ask. If C can be resolved, then I could say C.find requested dependency, group ID, artifact ID. Oops. And that, or I don't want requested, I want resolved. But that's going to be null in this case because the implementation configuration is not resolvable. I'll say to do. So maybe the thing to do here is I can make another version of this. Boolean should remove redundant constraint. Yeah, okay, you always return false. Yeah, I get it. So this version is going to take in a so that's going to take the group artifact version from the constraint, and it's going to take in a particular dependency configuration. And we'll make this kind of recursive. So I'll say, maybe I'm just kind of moving this stuff into this override. Because now I can use this recursively. Constraint get group ID. Constraint.get artifact ID. And that's not going to be null. So that's our resolve dependency. And if it can't be resolved, then I'm going to go through each of these other guys and say, so I'm going to adjust this one to return should remove new group artifact version, group ID artifact. Cool. Okay, so now we've decomposing this problem into ever simpler pieces that we may progress towards resolution. So if it can be resolved, then we're going to resolve it. Let's continue in this else case for the moment. If it can't be resolved, then yeah, great old dependency configurations. We can iterate over these and recurse into them. Extending conf. There we go. That should be pretty good. So we're going to go through them, and if we can find it in any of the extending configurations with the newer version, then it should be good. Otherwise, we can leave it alone. So let's just step through this and see it in action. See if the code I've written so far is still cromulent. It should be. All right, cool. So we're coming into this with the implementation configuration, which cannot be resolved, but we go and get the configurations that extend from implementation, of which there are 8: compile class path, runtime elements, default, and each of these are resolvable. And so like on the compile class path, it's going to have Spring Core 622. So I should actually be able to hit this breakpoint in a second here and find that we are looking at the compile class path configuration. Very good. And that within this context, we will be able to find the resolved dependency Org Spring Framework 622. And so this is where we can start comparing, is this guy newer or not? And this is, so I kind of need a version comparator. What is, and we do this all the time in like upgrade dependency version. So, but I don't have it memorized how to compare versions. So let's see. So we have this, so we can create a semver version and get a version comparator from that. So what I kind of want to do is I want to say which of these is the version we have older than the version that is being resolved. And so if I was comparing them to, I made a version comparator like this one that uses latest.release, I should be able to do that. So I could say which of making a version comparator for where all versions are valid and newer is newer, which of these is sorts closer to new is kind of the question. So let's see. So I can go over here and say semver dot validate. Is this an instance method or a valid? Okay, so this provides a validated version comparator. So our two version, that's version selection. So this is kind of where I want to say, latest release. I'm not worried about metadata patterns at the moment. I want to get back a comparator. And now I want to compare the version here. Okay, so here I have a latest released version comparator, and if I compare, so we've got the resolved dependency. I just want to look at this. So resolved dependency get version 622, constraint get version 621, and when I compare them, I get 1. So I can say if this comparison is greater than 0, return true. Otherwise, return false. And I should probably, so, compare string is deprecated. What am I supposed to do instead? Current version. I guess there's this compare function. Okay, yeah, fine. The version that takes null is the first argument. Fine. All right, so that's not deprecated. It is a resolved dependency. So I guess I could say if and for the constraint or all right, just make some warnings go away. Okay, cool. So now we finally have our, here we go. So here we finally have our condition to remove, to proactively identify that this should be removed. And this guy looks like a great candidate to be a static field. No need to reinitialize this all the time. Oops. Let's go make you a static field. You are the version comparator. I feel like that's the appropriate tone of voice for any all caps variable. Oops. Version comparator. Okay. So now we're in here, and this is about to return. Well, I guess I just changed up the code. But let's go watch this in action. So here we go. We've gotten into here, and we're about to return true from this method to say, yes, I have found something. Yes, I found a version that is redundant. Let's get rid of it. So let's unwind this. You're going to return true. You're going to return true. Now our check, should I remove this, is going to return true. And this, and now we finally return null to say, hey, let's get rid of this entire method invocation. And this is something you can kind of do in general with Open Rewrite visitors and with Open Rewrite utilities like list utils. Any method that you return null from, or any visitor method or any list utils method, that you return null from, is going to interpret that as delete the irrelevant element. And you could do that even when your methods might be annotated as not returning nullable values. Nullability is a funny thing. Anyway, so that's going to return null and go into the framework. And I think we can let this go and now see how things have changed. And hey, would you look at that? We have, our test is failing, true, but we've deleted the important thing, right? We've now have deleted the irrelevant constraint, and now we just need to kind of add some code that's going to clean up the constraints block itself if it's empty, because if the whole point of a recipe is to clean this stuff up, we don't want to leave behind junk that still needs to be cleaned up elsewhere, even if usually you'd imagine there'd still be like one constraint, there's probably still be a constraint remaining. Okay, so here we have our constraints matcher. So this is done. Do we want to run another visitor after this one? So maybe what I want to do is split this. I could handle it both within this one visitor of both remove the actual constraint and then remove the then empty constraints block. And I think I can do that without making too much of a mess of things. And we are kind of at the scheduled end time of this live stream, but I don't have a meeting that I need to run off to after this. And I kind of just want to see this through to completion. So if you're in the audience and feeling like the time is up and you got to go, I won't blame you, but I'm just going to go ahead and keep working on this because I feel like I've got good momentum now. Although in retrospect, it was maybe wildly optimistic of me to think that I would get to authoring not just one, but multiple recipes live. So I think we're going to finish the changes for this recipe and end the stream there, even if that takes another 10, 15 minutes. Just think of it as bonus, anyone who chooses to hang around with me and do some recipe authoring. Okay, so this is good. And what I kind of want now is an alternate code path here. So we want to keep this for removing the constraint. And I just kind of want to also add something that's going to identify an empty constraints method and remove it. So I think this is where I will say, so the stuff here, and just to organize for myself, I might write a comment, remove an individual So I want to split this into removing an individual constraint and remove an empty constraint block. And so I think I will we'll get back here to that. What was our method matcher? Yeah, because we had the. So we'll call you now the individual constraint matcher, and make another one that is that matches constraints. And so I kind of want to say if constraints matcher matches M, and then here we have an else if individual dot matches M, and then we'll kind of stick everything that we have in here currently inside of this code path. And that should keep everything working the same. And this is where, and you might be like, well, hey, look, you're about to process removing the constraints method before you process removing the individual constraint. Like if you do this in the wrong order, then the constraint will still be there when you check if you need to remove the container. But anyway, let's continue. I don't actually want that suggestion. So this is where I want to say if m get arguments. So this constraint is going to have a if it's empty, or if the zeroth argument is not a lambda, we're going to return early. We don't need anything more here. Let's go. So let's hit this in the debugger and take a look. And what's actually going to happen here? So it might look like I'm. Lambda. Cool. All right. I can spell given enough attempts, and red squiggly lines in dictionaries to help. So yeah, so this is going to work. Like we're going to, so I put 2 breakpoints here to kind of illustrate a point that I think is important to understand about recipe authoring and traversal. Like obviously, what we want to write now is logic that removes an empty constraints block. But this block isn't going to be empty until we remove the individual constraints from within it. And we can handle these kind of at the same time because we're effectively doing a depth first search here, right? The very first thing we do in this visit method invocation implementation is visit sub elements. So that means the inner stuff is going to be handled before the outer stuff. And we could, do super.visit method invocation later, as we actually saw elsewhere in this same recipe, if we wanted a different behavior. But for this operation of remove stuff from the inside and then remove the wrapper or container around it if it's empty, that works really, really well, actually. So that's incredibly convenient. So this is going to go through, and we're going to, all the logic we already tried out for remove the individual constraint is going to happen. And then we come back around to look at the now empty constraints block, which I guess is only mostly empty because it still has kind of an empty an empty return statement in it. Because in Groovy closures, logically if the last statement or the last statement or expression within a function is just like implicitly returned from it, we still have the return the return statement modeled explicitly in the LST. So that's how we ended up with an empty return, which maybe highlights for me, like what I wanted to do here is just say, hey, if the arguments, this guy is a lambda and it has 0 statements in it, or the only statement is a return, get rid of it. Yeah, so that should be fine. So let's go get the lambda body. So m.get arguments.get 0. This is our lambda. No. So this is our lambda, and fl get body, and this is always going to be a j.block. I mean, practically speaking, it's always going to be a j.block, but hypothetically, I might be able to find a way that it wasn't a j.block, but I'll get body. And so here is where we want the body, and if b.get statements. Let's go hit this breakpoint, but I think that what we will want to do is we could probably just add a visit return and say if return.get expression, just add something here to clean up any empty returns. Maybe like, you can't do that. And I'm like, yeah, I can though. All right. So now since I'm going to add a visit override to clean up empty return statements. Oh, I'm still going to need to probably mess things up. I didn't call super.visitReturn. Yeah, I messed things up. Okay, that should unmess them up. Okay, so this should get rid of any totally empty return statements like the one we saw inside of that lambda body. And stuff like this is why I find it so convenient to kind of like program recipes with the debugger active, because even my mental model of what the LST looks like, they can almost just check the correctness of that against what I'm actually seeing in the debugger. I didn't hit the breakpoint I expected to hit, so let's move it a little bit earlier and try again and see exactly where I messed up. But yeah, I always remember reading, I've never programmed in Smalltalk. I don't know if any of you in the audience have, and do not take this as me saying that Open Rewrite is going to implement Smalltalk support. But when I've heard senior developers opine about the Smalltalk developer experience, I've heard it said that was a really good setup for coding in the debugger, as it was a very like message passing oriented programming paradigm. So the zeroth argument. Okay, so this is the part I got wrong. m.get arguments 0. I didn't mean to click that. The 0th element is a lambda. Oh, I meant to negate this. Of course. I wanted to return early if it isn't a lambda. I'm going to blame some of my bad typing. There was I'm blaming on the live stream itself, taking up a CPU cycle or two. I'm going to call that lag. I like to play online games, as many of you do, and lag is always a convenient excuse for why you got zapped instead of your opponent. And I figure, why not apply that same thing to this? All right, cool. So fix that conditional. Don't need my Zoom reminder at the moment. Okay, cool. So now we're looking at the lambda body, and what we should be able to check now is just, hey, if it has an empty body, if there's no statements in here, let's just get rid of it. So this is where we can say if b get statements is empty, return null. Otherwise, we shall return M. All right, I think our test is going to pass now. I think we're going to successfully remove this constraint, which if it works, I think will more or less bring us to the end of our recipe authoring exercise. Although I do note that the version of the recipe here does allow the optional specification of group ID and artifact IDs. So I should probably respect that in these configuration parameters in here. So can I do that real quick? Let's see. So I wanted to say if the constraint matcher matches, where's the best place? So I think this is where we're going to look at individual constraints. And I guess it could be inside if this should remove redundant constraint function. So yeah, I think right here is where we could compare this group ID, the group ID of the individual constraint to the optional configuration parameter of the recipe in order to return early. So we're going to use a Gradle dependency matcher here. Now this is what we did here, but this trait is about Gradle dependencies, and we're looking at Gradle constraints. But I don't know if this might still work for us. So let's see. Can I just could I use this directly within our should remove redundant dependency constraint? Oh, I can. I just want to see if this optional is going to be empty or not. Well, I guess these values are empty, so of course it's kind of going to be empty. Yeah, so you're an optional dot empty. But if you weren't empty, I could say so this is where so does this recipe and its other versions require no, it allows these to be null, and then that just matches everything, and that's kind of the behavior I want here too. But this guy returns early if that's there. Let's see. How should I think about this? Yeah, I don't know if this is quite appropriate for dependency constraints, because yeah, we're not really working with the dependency, we're working with the constraint, which is similar, but not exactly right. So what I could say here is if group pattern, what do we have? It's the globutils. Shoot, what's the name of the thing? We use it all over. Use it all over the place for pattern for matching group IDs and or to matching things with stars. Declared group artifact should resolve. I know. It's like it's on the tip of my tongue. The name of the utility that is it dependency matcher? Is this it? Yes, dependency matcher. Yeah, string utils matches glob. So yeah, I could do this directly, or I could use this dependency matcher, but I've kind of already done the dependency matching. So I think this is basically all I want. So this is where I could just say if group pattern is not equal to null, then if it's not equal to null and this doesn't match, then we shall return early. Let's do the same thing for artifact ID. Cool. All right, so now I think that this should take into, if it does match, we'll continue, and if it doesn't match, we'll return early. Okay, I think that's right. Should probably add a test case that covers the use of these parameters, but I think this change is now broadly complete with respect to being able to now also remove unneeded dependency constraints. Now, kind of the one question that I have for myself is, should this be parameterized? Should the recipe always behave this way? I think it should, because there's just no, like, if you're already on a newer version of the dependency, there's just no value to keeping this constraint block around. Like someone who doesn't know better someone who doesn't know better, someone who doesn't do the analysis is going to look at this code and think, oh, we're using Spring Core 621, and have no idea, unless they actually interrogate the dependency graph, that you're actually using 622. So I think this is probably not an opt-in behavior of the recipe that we would add a parameter for. I think we just always want this behavior, because there's just no good argument I can think of for keeping this block around in this situation. And in the forms where we are using strictly or something else, we should already not be making a change. Okay, so I kept all of my changes to this quite self-contained, so I shouldn't affect any of these other code paths and cause any of these other tests to fail. But let's go and check if that's the case. Always worthwhile to check your assumption that you are haven't messed anything up. As if it was that easy to never mess things up, wouldn't need as many automated refactoring tools and recipes and all of those fun things. But yeah, this is looking pretty good. This is looking like I've added useful functionality to this recipe and not regressed anything. So yeah, it's looking pretty good. It's looking pretty good. Let's go ahead and commit that. And I will leave uncommitted my other unfinished recipe that I'll go work on after the live stream. But let's go ahead and let's go get this pushed up so that everyone may benefit from this enhancement. Now let's just slap a quick format on there. Are there any more warnings I should clean up? There's some warnings in this recipe, but they weren't in my changes, so I'm not going to worry about them right at this second. Enhance, remove redundant dependency versions to remove unneeded dependency constraints, which incorrectly suggest to readers that an older version of a dependency is in use when it is not. And I already checked the warnings aren't in the changes I made, so I'm not going to worry about those right now. So I'm just gone ahead and pushed that up to push rejected. Yeah, okay, I should rebase and get the latest changes. Everyone's always actively developing away on open rewrite, but I don't expect any merge conflicts. And boom, there you go. So, hey, we took an hour and a half or so and added a useful code quality cleanup. And this is were you to come to the Code Remix Summit, the kind of thing that you and I might do together on the hack track, right? Like if there's some bugbear about your code base, if there's something that you want to fix everywhere or have been instructed to fix everywhere, and you know that a recipe would really cut down on the labor involved in, getting rid of that anti-pattern or applying that best practice, but you're not quite sure how to go about that, come see me at Code Remix Summit and we can work on it together. And I hope to see you there. And until then, I think this is a good place to end the live stream. I've been Sam Snyder, VP of Engineering at Moderne, and you have all been lovely. Thank you so much.